Okay, I've got a couple of blocks, velocity, having a velocity coming right at each other. They collide. Okay, I know the coefficient of restitution is 0.75. I want to find the velocities after impact. So, here's what I do. Whenever I've got an impact problem, I've got a couple of things I can do. First of all, I recognize that momentum is going to be conserved for this system as a whole. Okay, in that the total initial momentum equals the total final momentum. And that's because with that collision, the impulse of them colliding is an internal system. If I take them together, or is an internal impulse, internal force, right? So it's going to cancel out equal and opposite reaction, Newton's third law, if I take it as the whole system. So there's no external impulse, so momentum is going to be conserved. Okay, so when I do that, I'll start with point A, or block A, and I get 0.6 times 4. Okay, block B is going in the opposite direction, so it's minus 0.9 times 2. So that's my initial momentum. It's going to equal the final momentum, which is going to be 0.6, and that'll be the velocity of A2. And again, I don't know what direction these are going to be in. They might be both to the right, both to the left, opposite directions. Okay, I'll just assume they're both positive, and we'll see what happens. So we get 0.9 VB2, right? So that's one equation with two unknowns, right? The two final velocities, okay? Now the other equation that I've got is the coefficient of restitution equation, okay? Which is basically the difference in the final velocities divided by the difference in the initial velocity. So I'd have something like VB2 minus VA2, again, those two unknown final velocities. And then I have VA1, which is 4, minus VB1, which is negative 2. Okay, that's the coefficient of restitution equation. These are the two equations that you typically apply with any sort of impact problem, right? Your coefficient of restitution equation, as well as the conservation of momentum for the entire system here. Okay, so from that, it's two equations, two unknowns. I'll let you do the math on your own, and you can find out that the velocity of A is going to be negative 2.3 meters per second. And the velocity of B after impulse is going to be 2.2 meters per second. So A actually they basically hit and bounce back in the opposite directions on these. That's what the negative sign tells me, that A is going to the left, positive B means to the right. Okay, but it's basically you set up those two equations, two unknowns, solve using algebra. That's generally how we do these impact problems.